Okay, this is Mrs. A with a short video on inequalities. So, over the past few weeks, we've learned about how we write an inequality in math notation, and we've learned about how to graph an inequality on a number line. We learned how to test a point in an inequality to see if a value would meet the condition of that inequality. And we learned how to solve an inequality with the whole goal to isolate the variable, let's say x, and we do that by using the distributive property first, by combining like terms, and then lastly by dividing or multiplying. I think we did a good job with that. Then we moved on to compound inequalities, and here's where I feel like there are a lot of questions, so I wanted to make this video today. I noticed on the test on Friday that we were still struggling with this, and I think a lot of it's because a lot of people were out sick, and that definitely made that a challenge. So let's cover that again. Compound inequality, it's two inequalities joined. So that's it. It just means that we have two inequalities and they're brought together into a single statement. There's two types of compound inequalities. There's an and an or. What I'm going to focus on in this video is and. Okay, so what an and looks like. So let's say if we were to write out an and statement, it would look like this. We would have 2 is less than x and x is less than 5. And that's it. That's what the statement would look like. We would see that as like a single problem. Let's say if it was problem number 1. Now, there's another way that we could write this. This could also be written as 2 is less than or equal to x is less than 5. The word and becomes implicit in this equation. We're basically saying 2 is less than x and x is less than 5. We usually just say 2 is less than x is less than 5. So let's see how we work with these types of equations. So the first way we could work with this type of equation is we could look at these as the two separate inequalities. And we know how to work with these two separate inequalities, right? So if we wanted to solve 2 is less than or equal to x, and we wanted to place that on a number line, let's draw our little number line, and we have our 2. We know that x is greater than 2. So we know that greater than or equal to 2. So we know that we're going to have a closed circle, and our vector is going to point to the right. And if we want to plot x is less than 5, we would put on our number line, we would put the 5. And since it's less than, it would be open circle. And we would have it go to the left because it's less than. And that would be how we would plot each of those two inequalities. So the second one was x is less than 5. Now, with an and statement though, with something like 2 is less than x is less than 5, or we could say 2 is less than or equal to x and x is less than 5, our answer for x needs to meet both inequalities. It needs to meet both conditions. So we're really just looking for the answers that fall within here. And any answer out here doesn't really work. So let's give an example. Like if I have, let's say I have 0. 0, if I put 0 into the first equation, is 0 greater than or equal to 2? No. But is 0 less than 5? Yes. So 0 meets one of the inequalities, but it does not meet the condition of the other inequality. So it's not part of the solution set. Let's try the number 6. If I put 6 into the first inequality, 6 is greater than or equal to 2, but 6 is not less than 5. So again, it does not meet the conditions of both inequalities. Let's try a number in the middle. Let's try 3. Is 3 greater than or equal to 2? Yes. Is 3 less than 5? Yes. So that shows how the number line would look. But there's an even better way, a neater way to write this out on our number line. So what we would do is we write the lowest number, which is 2. We write the higher number, which was 5, and then we draw a line between those two. And we make sure to use the correct symbol for that inequality. So for less than 5, we want to make sure it's an open circle. For greater than or equal, we want to make sure it's a closed circle. And so that's what the number line would look like for 2 is less than x is less than 5. So hopefully that made sense. Let's try a problem. So we've got, let's see, in the practice problems, one of the ones we had, I think it was A, we had -4 is less than x minus 2 is less than 3. So first thing we can do is we can break this into two inequalities. Now remember, we're taking the first expression and the second expression, not just the x. We're going all the way through to the whole second expression, and this is our third expression. So our first inequality would look like this. -4 is less than x minus 2. Our second expression would look like this. X minus 2 is, actually let me use a different color for that. Let's use blue. So the second equation would be x minus 2 is less than 3. That gives us our two inequalities. Now we already know that we want to simplify them. We want to isolate the variable x so that it's easier to see and understand. So let's look at the first inequality. That would be, let's see, we're going to move the -2, add +2 to each side. So that would give me -2 is less than x. That's nice. And then over here, we're going to isolate the variable. We're going to add the 2 to each side, and we get x is less than 5. So that gives us our two inequalities. And what we could do is we could definitely just, at this point, we could put them on the number line. And so we would put -2, and we would say x has to be greater than -2. So open circle with the line going to the right. And then we could say x is less than 5. And we would put our 5 on the number line and say x is less than 5. And in this case, both inequalities have an open circle. And so we find our overlap, because remember, the inequality, the solution must meet both inequalities, right? So our end graph would look like this. Put the 2 and the 5, sorry, -2 and then we're going to 5, put our two circles and close it up. And that's what that would look like. Now if we wanted to write our statement with the and, we could say -2 is less than x and x is less than 5. But we're also not comfortable, right, with writing that together as a single inequality, and a compound inequality, and we would write it like that, right? The lowest number, the x, and the 5, and we're using the same inequality symbols. And so that would be our answer. Okay, so let's try B. So B in the practice problem set, that was, let's see, B was -3 is less than -2x plus 1, and that's less than or equal to 9. Why don't you pause the video here and you try it. Give this a try. And then when you're done, come back and continue. Okay, so I'm guessing you've tried this problem and you have a solution, and we're going to see how your work compares to my work. All right, so the first thing I'm going to do is I'm going to write out the two inequalities. I've got -3 is less than -2x plus 1. You know what? Again, I want to just keep these in two different colors. Let's try that again. So I'm going to do -3 is less than -2x plus 1. I'll do my second one in blue. The second one, again, remember, I'm taking the entire expression here. So I'm taking -2x plus 1 is less than or equal to 9. That gives me my two inequalities, but I want to isolate the variable x so that I can better read it. There's too many numbers to get a clear picture of what this inequality looks like. So let's see, the first thing I'm going to do is move over the -1. So I have -4 is less than -2. Let's do that again. So -4 is less than -2x. And then we're going to divide each side by -2. And that's going to give me 2. I have to flip the direction of the inequality because I just divided by a negative. And that's x. Okay, let's try the blue side. So now we have -2x plus 1 is less than or equal to 9. So I'm going to do the second step because there's no distributive property step here. So I'm going to combine like terms. And then I have -2x is less than or equal to 8. And then I'm going to divide each side by -2. And don't forget, we have to swap this, we have to flip the sign. We have -4. Okay, so that gives me my inequality. So I could even just write this out, but let's stick to our approach. First we're going to draw this on a number line and see what that looks like. But I'm sure you're starting to see there might be quicker ways where we can avoid the hard work. I'm going to start with the -4 because that's the smaller number of the two. So I'm going to say -4. That one I'm working on this blue one over here. So x has got to be greater than or equal to -4. So that's a closed circle. And I'm going to go to the right. And then for the purple, let's see, I'm over here now. 2 is greater than x. Okay, so x is less than 2. So I'm going to write my 2. And I'm going to keep an open circle and go to the left. And now I'm looking for my overlap because I know that my solutions need to meet the conditions of both inequalities, right? Anything out here just doesn't meet both inequalities. So a better way of writing that, making that look readable, would be to simply write -4 and 2. Make sure I keep my circles closed or open based on the original problem. And that's what I get. And I started off with a compound inequality, but we're going to write out that simpler one now. So I would have -4 is greater than or equal to x, which is, let's see, I just did that wrong, didn't I? I apologize. Let me erase that. Where's my little eraser? Here, let's try that again. I just even said that the wrong way, didn't I? So we've got -4 is less than or equal to x. And then we have x is less than 2. Now I'm happy. Okay, so that would be my answer right here. Did you get the same thing? Okay. All right, before we go, I just want to show you that I'm sure you started noticing there might be quicker ways as you were doing this. And yes, you were right. Because you start noticing that we're kind of doing the same thing a couple of times over and over and over again. So if you feel good about what we just did above, here I'm going to show you a little faster way of doing this to avoid the hard work. And this is really where you want to be. You know, if you can get here by tomorrow, that would be great because this is going to save you a lot of time. So if I have -4, I'm going to go back to problem A, and I'm going to show you a faster way that we could be working on these problems. And I'm sure you might have started to notice it as you were doing those problems. Well, what I can do is these are 3 expressions, and my goal is always to isolate the variable x, right? So I can apply my same rules that I use for equations and that I had been using all along for inequalities. I can apply them to compound inequalities. I just have to be careful and recognize again that I've got 3 expressions going on here. Okay, so what I could do is, the first thing I want to do is remove that -2. So I do that by adding a 2. But you have to do that to all 3 expressions now, right? Okay, so then that would give me, there we go. We're adding 2 to all 3 expressions, and that would give me -4 is less than x is less than 5. Do you see that? Let's see if that's what we had gotten before when we did A the first time. What did I do wrong? Oh. All right. Mrs. Amarster is probably losing you by now, right? Here we go. -4 plus 2 is -2. There we go. So we got -2 is less than x is less than 5. Let's go all the way back up to the top again. There we go. -2 is less than x is less than 5. So I'm going to do that one more time just because I feel like I want to make sure I didn't lose you all there. And let's see. So if I wanted to, I'm going to add 2 to each of the 3 expressions. -4 plus 2 is -2, which is less than or equal to x, which is less than 5. That's my expression. And if you look back again to the beginning, you'll see that that was the expression we got before. So you see how we can do that in a single step and not have to break up the inequality, the compound inequality, into 2 inequalities? Okay, and then it's very easy to graph this as well. So if I wanted to graph this, got my number line. I'm just going to put in -2 and 5. And to graph it, I've got the -2. This would be open. The 5 would be open. And I can just graph it like that, and I'm done. And again, let's go back to A and make sure that when we did this the longer way, we got the same answer. And we did. So hopefully you can see that. Let's try this again. So our answer now would be this area here. Okay, let's try this again for B. Okay, so B, we had -3 is less than -2x plus 1 is less than or equal to 9. Pause the video and you try it now, the way that we just did, where there was less hard work. When you're done, unpause the video and let's compare our answers. Okay, I'm guessing you tried this and you're coming back now to see how your answer compares to mine. Okay, so the first thing I notice is I don't have to do anything with the distributive property. However, what I want to do is get rid of to isolate that variable in the middle, I want to subtract the 1 from all 3 expressions. That gives me negative 4 is less than negative 2x is less than or equal to 8. Okay, what's the next step that I would do? Right? I would do step 3, which was divide or multiply. Here we're going to divide by negative 2. Divide by negative 2. Divide by negative 2. And so negative 4 divided by negative 2 is equal to 2. Now remember, what do I do whenever I divide by a negative? I have to swap the direction, flip the direction of the compound inequality sign. So that means I have to flip the direction of both signs. I'm going to flip that, get x, and now I have to flip this sign as well. That gives me negative 4. And that's my answer. One thing I like, though, when I am working with compound inequalities, I like to read them from smallest to greatest. And so what I might do is take this and flip it around. This equation is the same as saying negative 4 is less than or equal to x is less than 2. And I'm sure you can see that because we've done a lot of work with that in our inequalities. If not, just take a look back and see if you can see why that's true. And I'm sure you can see why it's just easier to work with when it's in that direction. Both are accurate. You know, if you gave me either of those statements in Edulastic, I would give you full credit. It's just that the second one is easier to read and easier to graph on a number line. So let's see. I'm going to put negative 4, and I'm going to put my 2. And I am going to have a closed circle on the negative 4 side and an open circle on the 2 side. Okay, Mrs. Morse here is hoping she got the same answer for B as she did up above. So it should be negative 4 is less than x is, and equal to x is less than 2. Let's see, so for B, negative 4 is less than or equal to x is less than 2. Perfect. And we should have closed circle, line, open circle. Let's see. Closed circle, line, open circle. We did it. Okay, so I'm just going to put a square. This is my answer over here. Okay, so I hope that helped. That's how we do and statements. Please see my next video for or statements. You're going to be relieved because there's really no difference from or. It's just like how we used to solve inequalities. It's going to be so much easier. Where you really want to get your focus and your work done is on these and statements. So please practice them. See if you can spot them in your study guide and see if you can practice them and use the steps that Mrs. A just did today. Have a wonderful day.